Welcome back, everyone. We are finishing our discussion on probability, and we're going to end our whole probability topics with permutations and combinations. So let me kind of explain permutations. With permutations, whenever all selections come from a single group of items, no item may be selected more than once, and the order of arrangements, so for example, ABC, would be different than CBA, and I'll explain that in a second. Meaning, if every member of the group is selected in each possible permutation, then first we're looking at something called, and let me just show it to you here. Let me see, I'm going to try to use a color that would show up here. All right, it's called n factorial. You can see it up here in the description. When you see what looks like an exclamation point in math, we call that n factorial. And it means that you're taking that number, right? So you start, actually, let me just show you an example. I think it's going to be easier. If I had 10 factorial, then that would be 10 times 9 times 8 all the way down. Oh, I just ran out of room. So times 1. But you start off with that number. So here I would start off with 10. And you multiply each unit down. So, right, so 10 times 9 times 8, all the way until you get to 1. That is what a factorial is. And there is if you're on your scientific calculators, you should see that key, a factorial key. It's either going to look like the factorial key or it might say X factorial on it, something like that. But there should be a factorial key on your calculator. And so just for practice, if you were to click 10, oops, well, that just went off. If you were to click, for example, the 10 factorial, so go on your calculator, right, and click 10 factorial, then you're looking for that factorial symbol, and then you should end up with your answer. Now, I do know if you're using like your iPhones, it does have that on there. That's the phone I use, so that's why that's the only one I know. But I know on the scientific version of that one, there is that factorial symbol. Now, a permutation is when we are talking about, so it's whenever all selections come from a single group of items and no item can be selected more than once. Order matters. That's when we use a permutation. Why am I saying this now? Because then when we get to combinations, order doesn't matter. Let me explain what I mean by order. Let's say you have 3 positions. Somebody places first place, second place, and then we have third place. Order matters, right? The person in the first position is the person who got first place. So that's where we would say order matters, because it does matter whether it's first, second, or third place. If that is the case, if order matters. Now, when would order not matter? Let's say, for example, putting flavors of ice cream in a bowl. If you want to put 3 flavors of ice cream in your bowl, it really doesn't matter whether you chose chocolate first and vanilla second or vanilla first and chocolate second. That changes the formula. So we're going to start off with permutations where order does matter. And now you're going to kind of see this new notation. You're going to have an N here. P is for permutation, and then R. N is how many people or things, whatever it is you're looking at, that you are choosing from. So how many is in your plate, right? How much are you choosing from? And out of those, how many do you want? That's your R, okay? So out of N things, I want to pick R of them. This is your formula. Now, let's go down here and just do a little bit of practice. So 6 factorial, put that on your calculator. Practice now with that one and see what you get. So if you put in the 6 and the factorial symbol, you should get 720. Now with this next one, we have 8 factorial over 4 factorial times 3 factorial. Let me kind of show you how we can simplify this. So you have, actually, you can do this. I'm going to show you a different one with simplifying. But on your calculator, you should be able to put this on there. Let me just show you how I would probably enter it. I would take 8 factorial all over, and then here, I'm doing that. Actually, you could even do that first. You could take the 4 factorial times the 3 factorial, and whatever that is, then you take 8 factorial divided by that number. You decide which way is going to work best for you, but it should come out to be 280. And then with this one, notice we have to do a little math first because you have to do parentheses. So 17 minus 4 is 13 factorial. Now, yes, you can do this in your calculator. We just talked about that with number 2. But let me also show you how you could simplify. What I want you to look at for a minute is the number in the denominator. And look at the largest one. You have a 4 and a 13. I'm going to focus on the 13, okay? And I'll show you what I'm going to do next. So I'm going to simplify this by coming over here, and I'm going to write it out, right? 17 factorial is 17 times 16 times 15 times 14 times 13. You might think, is she going to go all the way in? No. What did I underline here? I underlined the 13, so I'm going to stop at the 13 then. In the denominator, I'm keeping what I have, so we have 4 factorial times 13 factorial. Notice what you have in the numerator and the denominator. 13 factorial. We can simplify and cross those out. That's why if I'm simplifying, I try to look at the biggest number in the denominator, and then that tells me where I'm going to stop. Now you can just multiply those out. You can take 17 times 16 times 15 times 14, right? Get that answer. And then divide that by 4 factorial. You should get 2,380. That was just a little practice because we're going to do a few problems today, and I want to make sure we're going to do our simplification process with these permutations and combinations. Here's an example. Now, you have a city that has 12 candidates running for 3 leadership positions. The top vote getter will become mayor. The second place vote getter will become the deputy mayor. And then the third place will become the chief financial officer. How many outcomes are possible for the 3 leadership positions? So this is where order does matter because the position depends on, so whatever, if you're in the first position, your title changes compared to the second position. So this is out of 12 candidates. And if order matters, it's a permutation. Out of 12 candidates, we're looking for 3 positions. And I want to show you a little shortcut that I use with my permutations. We won't be able to do it for combinations, but for permutations, let me just show you kind of what I call the quicker way. Notice the 3 at the right. That tells me how many dashes or slots I'm going to make. The 12 on the left tells me which number I'm going to start with. So I have 12 to choose from in the first position, but that one was taken. Then I have 11 to choose from in the second position, and then 10 to choose from in the third position, which gives me 1,320. Now you can use the formula. The formula states that you would take 12 factorial divided by 12 minus 3 factorial, just going back to the formula at the beginning of this video. That will give you 12 factorial divided by 9 factorial, which you can do that right on your calculator. But you will still get to the same answer. You choose the way you want to do it. I tend to take the other option. All right, a Little League manager has 15 children on her team. How many ways can she form a 9-player batting order? Yes, order does matter with this one because there's a batting order with this. That means out of 15 kids, we want to choose 9. Well, then I can do well, it depends on how you want to do that, but I have 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the one option. And then you start off with the 15, right? And then you just keep going. 9, 8, and then 7. And then you put that in. The other option, of course, is to use the formula. Either way, we'll get to our answer. It's a big number. It's 1,816,214,400. All right, that is the answer for that one. So that's how many possible combinations we could get for that. But now let's talk about combinations. This is when order does not matter. So now you are looking at, like I said, like the scoops of ice cream, which we're going to actually do next. It doesn't matter what order you put the ice cream in your bowl. There's just your 3 flavors of ice cream. So when order does not matter, then that's when we use a combination. And now you can see the formula changes a little bit. Notice now we're adding this. This is what we kind of put in there. So now we have n factorial over the n minus r, but now we have also times the r factorial. Now, I do have a link to a calculator. Remember calculator.net that we use for the whole finance chapter? Well, guess what? Calculator.net also has a calculator for permutations and combinations, but I don't want to use it yet. I just want to go over this first so we can get a little practice mathematically. Suppose you select 3 different flavors of ice cream to put in a bowl at a shop that carries 12 flavors. How many flavor combinations are possible? Again, we talked about ice cream. Order doesn't matter, which means now instead of a P for permutation, I'm using a C for combination. Now, I am going to use the formula just so you can see how it works. We have 12 factorial over, just using the formula, 12 minus 3 factorial, and then times the 3 factorial. Simplify. Use the parentheses first, so that's going to give me 9 factorial times 3 factorial. Now, remember, yes, we can put this in our calculator. By the way, certain calculators, there are certain scientific calculators that actually already have combinations and permutations on them. So look on yours to see if you have that ability. Remember what we talked about before. We look for the number, the highest one in the denominator. That's the 9. No, you cannot. Just so you know, you cannot multiply those together. So you don't get 27 factorial. So please don't do that. So I wanted to mention that one. So we have the 9 factorial. That means I write this out until I get to the 9, and then I stop. And then we have the 9 and the 3, because now I can cross those out. The 9, see, those just cancel out. What I'm left with is 12 times 11 times 10, and I'll write that out, the 3 factorial, since that's only 3 numbers. And so now what they multiply those out, you can put that on your calculator, but that gives me 1,320 in the numerator, but then divided by 6, which comes out to be 220. All right, so that's how we kind of apply with the formula. Now, look at example 2. Suppose you play a lottery in which the winner is chosen by drawing 6 balls at random from a drum containing 52 balls numbered 1 through 52. How many combinations are possible? Again, when you're playing numbers in the lottery, it doesn't matter the order that the numbers are picked. It just matters that you have those 6 numbers. So that would tell me that this is a combination. Out of 52 numbers, I need 6. Now, I already did the formula with you and showed you how we can work through that. So let's go ahead and jump to the calculator I was going to show you. And you can click on that. That takes you to calculator.net. It's the permutation and combination calculator. So I love this website because it gives me so many things. Our N here was 52. Our R is 6. And then we click calculate. It actually gives you both numbers for whether you're looking at a permutation or a combination. But we're looking at the combination. So I'm going to go back to our notes. And you're probably going to be like, why did you make us work through the formula? Because we got to work through that before we use the calculator. All right, this is the number that we get for how many possible combinations we get. Now, let's talk about probability with a combination. Find the probability of choosing 5 numbers that match 5 randomly selected balls when the balls are numbered 1 through 28. Okay, so the first thing we need is out of 28, we are choosing 5, right? Okay, so we're going to choose 5. But again, 28 and 5. So now I'm going to go to my calculator. We have 28, and we're choosing 5 of those. And it's a combination because we're just talking about numbers here. No order. Order does not matter. All right, so that gives me 98,280. That's not the answer yet. The answer says, what is the probability? Now, think about this. Out of 98,280 combinations, there's only one combination that would match the chosen numbers, right? One of them. Remember that the probability of event A is the number of ways event A can occur divided by the total number of outcomes. In this case, we just said that there's only one possibility out of all of these possible outcomes. This would be your probability. Now, if we want to take that a step further, okay, if we want to take that one step further and just divide so that we can actually get the, let's say, percentage. So I'm going to divide that. So 98,280. Let me just show you what I'm seeing on my calculator. 1, 2, 3, 4. I'm going to make sure I'm counting. 1, 2, 3, 4. 4 zeros, and then a 1. All right. That's the probability. As a percent, that would be 0.001%. Very, very small chance of getting that. Look at example 2. Find the probability of being dealt 5 cards from a standard 52 card deck, and the cards are 7, 8, 9, 10, and Jack, all of the same suit. All right, so let's talk about this. Out of 52 cards, I am choosing 5, right? Okay, this is going to be a couple step problem. I'm going to go back to our website. So out of 52 cards, I want 5. Okay, combination. So notice your number down here under combinations. So now I'm going to put 2,598,960. But we're not done yet because the question says, first of all, I need the probability, but I want a specific 5 cards. I want it to be a 7, 8, 9, 10, and Jack, all of the same suit. Remember, there are 4 suits, right? This is how many possible combinations we have, but there are 4 suits. So we want these particular 5 cards, but all of the same suit, but we have 4 of them. So it's not going to be 1 out of that number. It's going to be 4. Your probability is 4 out of that number because you want those 5 cards, but in that particular suit. But we have 4 suits. It doesn't say it has to be one particular suit. It can be any of those 4 suits. Okay, one more. A lottery game is played in many places and requires $1 per ticket to play. To win the jackpot, a person must correctly pick 5 unique numbers from balls numbered 1 through 28. Again, order does not matter. And correctly pick a final number, which is chosen from the balls numbered 1 through 18. This is a two-part type of winning. What is the probability of winning the jackpot? Okay, note that the randomly selected balls come from a single group of items. Each ball can be selected only once, and the order in which the balls are selected doesn't matter. So the first pick, because remember there's 2 of these, the first pick is out of 28 numbers, we need to get 5 of them. Okay, 28, we want 5. So we're going to go back to here, and we get 98,280, which we did in a previous problem. We got the same answer for that, but just to do it again. 98,280. Note that out of that possible combinations, there's only one that's going to be the winner. So the probability here is going to be 1 out of 98,280. But we are not done. Because remember, there's a second one. We have to find the probability now of choosing a number from the balls numbered 1 through 18. That's going to be out of 18, we want that 1, right? We want to get that winner, whatever that 1 is. By the way, I'm not even going to go to the calculator because whenever you have a combination where R is 1, your answer is just N. So 18, right, C1 is just 18. Now, out of the 18 combinations, there's only one winner here. So that probability is going to be 1 out of 18. Now, I'm going to move on to the next part because we're not done. This one says, okay, so what is the probability of getting this number, right, these 5 numbers, and this number? Ah, this is an and problem now. We want the probability of getting both of these. So the first set of 5 and this extra one. Remember, with and, you're multiplying. So I'm going to take these two probabilities and multiply them together. That's going to give me 1,769,040. That is your probability. If you want to look at it as a decimal, let me go ahead and calculate that. It's very small. I'm laughing because it's very, very, very small. So if you look at your calculator, I've got to count my zeros. 1, 2, 3, 4, 5, 6. I think I counted that right. 1, 2, 3, 4, 5, 6. And then we'll round here. I'm not going to go further than that. Very, very, very small probability of winning. And this is typical with most lottery games. Your chances are going to be very, very small. But that's just something to be aware of. And if you play, you play. And if you don't, you don't. All right, so that ends this entire unit now of probability. And we will be going on to the next video, which will be statistics.